Okay, it's time to begin. I sent you this morning via ALEKS email a list of practice problems that you will need to complete. You should print these off and have them next to your computer tomorrow for us to go over them. And so at any rate, that's just simply it. You need to have those available. I need to adjust the screen just a little bit. There. Okay, so let's go ahead and get started on today's assignment. Helps if you turn it on. Okay, today what we're going to talk about is something called piecemeal functions. In this case, I give you two separate equations. Now your overall graph is composed of this piece plus this piece. But we have these constraints on these pieces. Now, x squared plus 1, that's a parabola that's moved up one place from the origin, like we have over here, and you can see this dashed line right here would complete the parabola. Because of this restriction, x has to be less than 0, then 0 itself for x is not included, and none of this stuff on the positive side is included. So that leaves us a graph that looks like this half parabola. The second equation, x minus 1, that's a line. The slope is 1 over 1, and the y-intercept is -1. Here is the entire line. Y-intercept of -1, up 1 over 1, up 1 over 1, and so on. But this one has the constraint that the x values can only be greater than or including 0. So it would be this part of the line, and we're basically discarding that part of the line. Now, the question this asks is, what is the y value if x is -1? Okay, well, we look back here to the graph again. If x is -1 right here, then the y value down this way, there is no y value. Up here, you have the point 2 right here. Okay. The second one, what is the y value if x is 0? Well, right here is the only y value because that one's not included. If both of these were there, if that was an included point, then you would have two solutions on this. So in this case, just simply that point or -1, x would be -1. Or y, excuse me, would be -1. What if x is 5? 1, 2, 3, 4, 5. And that's up 1, 2, 3, 4. So the point 4. And this is the basic way that piecemeal graphs are put together. Okay, here's another one, and I've got some scribbles on this. Now, as we look at this, I look at these, and before I even start graphing them and stuff, I consider what restrictions do. If this is your problem, it wants to know where x is 1, would x be, can x be 1 given that all values of x are less than 2? Well, yes, it is. So we have to consider this equation for that problem. What about this equation? 2 is smaller than or equal to x is smaller than or equal to 4. Is 1 part of this set? Well, no. So we don't even need to consider this equation for this problem. Now, what about this one? X's number is bigger than 4. Well, 1 is not bigger than 4. So for this problem, we only have to consider that first equation. Okay? And you get an answer of 4. How do we get that answer? 1 squared plus 3 is 4. Now, let's go to our second problem. Which problems can be considered for this one? If x is 4 is equal to 4. Here we have an or equal to 4. This one is bigger than 4, so we can't use 4 on this one. So the only one we can consider is that middle equation. And when we replace x in it, okay, we get the value 7. Which, if you think about it, this is just a simple line. Now, for the third one, over there, well, if x is 3, 3 won't work for this one, and 3 won't work for this one. So this is the only one that's a possibility because 3 is between 2 and 4. So in this case, we would have the point 7, and that would give us that line. So if x is 3, y is 7. If x is 4, y is 7. If x is 6, y is 7. In other words, that's a horizontal line. Okay, what about h of 5? Well, 5 would work with this, won't work with that, won't work with that. No, wait, this is x is bigger than 5. So yes, it would work with this one, and yes, it will work with that one. Okay, so in this case, no. Let me start all over. 5 won't work with this one because 4 is the biggest it can be. In this case, 4 is the smallest it can be, so 5 will work with it. So we put 5 into this equation. 2 times 5 is 10 minus 1, and we get 9. So that's what we call evaluating piecewise equations. Okay, here's another one. Well, we've got this set of answers. If we don't want to try out all 3 of those for each of these answers, then we'll do an analysis like I thought. Which ones will this work with? X is less than -2. Well, -3 is less than -2. Okay, so x plus 7. X plus 7 will work with this one. What about the middle one? -2 is the smallest value it can be. So -3 won't work for the middle one. Here, all of this is bigger than -3. So this is the only one that'll work here. So in this case, we put -3 in here. -3 plus 7 is 4. So f of x equals 4. Okay, let's do the same analysis on this one. It wants to have a value of -2 for x, but it says x is less than that. So we can't use that one. Or equal, so yes, we can use this one. And this one's too big. So the -2 is less than or equal to x is less than 1 is the only one that'll work on that one. So if we take x squared and replace it with -2, and we get 4. Okay, the next problem. If x is 1, won't work on the top one. Won't work on this one because this is less than and that's equal. And this one it will work on. So we can try this one. And the answer is simply going to be 3. Part of a horizontal line. Okay, here. Where can it be 4? Well, can't be the top one, can't be the second one, can be the third one because it's got the or equal. So again, the answer on this one is just going to be 3. Let me rewrite that middle equation. So I'm going to stop it there. That's close enough. Now I can see those. This time it asked us to graph them. Well, this has a y-intercept at +1. And it goes up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2. So in other words, the whole line would be through here. Now, it says x values can only be less than 2. 1, 2. So that means that this is only that part of the line. Okay. Now our next one, -x minus 1. -1 is my y-intercept, and the slope is down 1, right 1, or up 1, left 1. So down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1, down 1, right 1, and so on. Now, I can only use those values where x is greater than 2. 1, 2. So that means I can only use this part of the line, and because this one is or equal, I can have a solid dot. On this one up here, I have to have an open dot for the top one. They did an XY table to do it. I graphed it by the slope intercept form, which is generally faster. Okay. Uh-oh, they're saying I made a mistake. This is the first one. Oh, it's greater than +2, not -2. So yes, it should come here. Okay, hopefully you won't be as careless as I was right then. Okay, here, as you can see, it's simply from +2 to the right. Here, from +2 not included to the left. Okay, we got to graph these again. Horizontal line at -1. X is less than 0. So in other words, we're just going to have this. Okay, the next one, X -1. So here's the y-intercept. Oh, by the way, this would be an open circle there. But on the second line, let's see. X -1 starts here and goes up 1/1, up 1/1, down 1/1, down 1/1 in that direction. And it only has it between X is 0 included and X is +2 included. So in this case, that would be that graph. Now the third one, 2x, -2x + 6. 1, 2, 3, 4, 5, 6 up here. Okay, 6 would be about here. And then down to right 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. And the constraints on that, X is greater than 2. So here's 2. That's not included point. And it would be these points going this way. Okay. So we're throwing away that part of the line. We're throwing away this part of the line. And we're throwing away this part of the line. And there's your graph. Again, it's far easier to graph these things using the slope-intercept method than it is to plot points. Okay, on this one, we're supposed to graph it. So that's going to be a horizontal line. Here, let me draw some graph paper. That's going to be a horizontal line at 2. But it's only going to use the part that's less than or equal to -1. So here's -1 and it's or equal, so it's a solid dot. So we throw away this piece of it. For the second one, -2x + 0. There's a +0 here, so the y-intercept is 0. Now this is going to go down to right 1, down to right 1, down to right 1, up to right 1, up to right 1, like so. Now let's see what part of this we use. Now remember, this is a solid point here because of the or equal. Now this time it says X is greater than -1. So we've got an open circle there, and x is greater than -1. So that would be this part of the graph here. So we throw away that, we throw away this. That is an open, but that is a closed. The domain is infinity to infinity. The range is infinity to 2. So let's see their solution. Well, they're not going to have a solution on this one. Okay, now we've got an absolute value problem. Have some graph paper here. If I have a pen, that'll work. All right. Absolute value of x graph ordinarily would look like this. And these are at 45-degree angles, up 1 over 1, up 1 over 1. Now it says it only is good from -4 inclusive to +2. Okay, if this is -4 out here, -3, -2, -1, +1, +2. Okay, so if x is less than -4, less than or equal, then this point would be included. And if x is +2, then this piece would be included. So that graph would look like that. Now let's look at the second one. The second one is going to be a line with the y-intercept at +2. Okay. Slope of -1, so that means it goes down 1, left 1, down 1, left 1, up 1, right 1, up 1, right 1. So it would be a line like so, and it says it's for x is -2 or bigger. X is bigger than or equal to -2. So that would be everything starting here, including this point, and going this way, but it would not include down that way, just like it does not include this way or that. Okay, this brings us to our next term, increasing, decreasing, and constant behavior of a function. This one is incredibly simple. I'm sure you're glad to have that. Okay, now, from here, this x value right here, to this value, x value right here, y increases. So this one is increasing. Okay. Here, from this x value to that y value is decreasing. Okay. From this x value to that y value, y is the same. It's constant. That's really all there is to this. Now, let's look at this graph. How would we answer this graph? Okay, this portion right here is going upwards from out here at -infinity up here to -2. Okay, so how do we write that where it's increasing here? Well, that would be from negative infinity to -2 inclusive. But this is also increasing from here included to positive infinity. So we have to union that, okay, to, what is that? 2 included to positive infinity, not included. Okay, where is it decreasing? Well, the only place it's decreasing left to right is this section right here, from 0 to 2, x equals 2. So the answer then would be inclusive 0 to inclusive 2. Where is it constant? Well, it's constant from here to there. Okay? So in other words, from -2 inclusive to 0 inclusive. So that would be your answers on this one. That white duct tape's some good stuff. Okay. This is supposed to be a bracket, and so is that, and so is that. Well, actually, these are not brackets. I showed something incorrectly then. The reason they're saying that those are not included is because right here, it's also part of constant at that point, -2. Likewise here at this point, it's both constant and it's decreasing. So technically, it's not included at these turning points. Okay, what about this one? Increasing from negative infinity to 1, 2, 3, -3. Oh. Why is this never? Because this is going downhill from left to right. So don't make that mistake. So this is a decrease, that's a decrease, that's a decrease. So answer is never. Okay, what about decreasing? Forever, infinity to infinity. What about constant? There are no level spots. So the answer is never. Okay, here's our graph. On this one, left to right, it's increasing. So we would have from -5 inclusive to 3, -3. Union with this piece, -1 to 2. And that would be the increasing. The decreasing would be from 2 to positive infinity. And the constant would be from -3 to -1. like I said, increasing and decreasing is pretty simple. Now we're going to have something called relative maxima, minima, and maxima of a function. Here I happen to have a curve. Okay, this is kind of like a sine curve that you would get when you flip the string of a violin. Now, what this is saying is, compared to this whole graph, this is a relative high point or turning point. When they talk about relative maximum or relative minimum, they are talking about turning points. Here, it continues forever in a downward manner. Here, it continues forever in an upward manner. So we don't count those on relative maximum and minimum. We only count turning points on this. So this turning point is a high turning point or a relative maximum. Okay, now you can list this as the XY point and say a relative maximum at the point, this, let's call this 1, 6 fictitiously, or you could say the relative maximum is 6 at x equals 1. Likewise here, if this is the point, if this is x equals 5 and this is y equals 2, or in other words, the point 5, 2, and this is the point 5, 0. Okay. There are two ways you can write your answer on this. You can say the relative minimum at 5, 2, or you can say relative minimum of 2 at x equals 5. And if I recall, ALEKS prefers this second method of putting in the value. Okay, we've got a graph here. What are the relative minimums or maximums? Well, this continues forever, that continues forever. We have a relative minimum right here and a relative maximum or high turning point here. Okay. So this is asking the point what is the lowest point in a small interval. So this is -2, -1. Okay. Surrounding x equals -2. Again, saying that x is -2. Okay, here at x equals what has a relative minimum, -2. And that relative minimum is -1. So here again, you can see some of the ways of writing this statement. Okay, in this case, the highest point in this interval here, which is 0, 1, surrounding x equals 0. Or we can write that at x equals 0, we have a relative maximum of 1. Okay, this statement is basically the way I told you, a relative max of 1 at x equals 0. This statement and this statement are saying the same thing. Okay, we've got a relative minimum here, a relative maximum there, and a second relative minimum. You can have multiple relative minimums and maximums. Okay, so for this interval, where x equals -1, we have a relative minimum at y equals -2. At this one, where we have, it asks about a minimum again, where x equals 4, we have a relative minimum of 0. Here, at x equals 2, we have a relative maximum at y equals 3. Okay, this is an x cubed graph, y equal x cubed. This continues forever, this continues forever. In this case, there is no maximum because there is no turning point where it changes direction from increasing to decreasing. Here it's just, although it passes through the point 0, 0, it doesn't change the direction. And there is also no minimum in this one for the same reason. This is just called an inflection point. Okay, here we go. We've got a relative max where x is -2 and y is -3, or at the point -2, +3. I said negative a moment ago, I meant +3. Here we have a relative minimum where x equals 2, y is a minimum at 0, or the point 2, 0. Now, this completes the material that's on this unit test. Section 2.8 will be on your next unit test, on unit test 3. So let me get out of this PowerPoint and show you something else. Okay, this is the first page of one of the handouts that I sent you today. Okay. In this case, you would have to plot just each point on this graph. Well, yes, we can do that. For A, 2, 3, over 2, and up 3, 1, 2, 3. For B, -4, 6, 1, 2, 3, 4, and +6, 1, 2, 3, 4, 5, 6. And for E, square root of 2. 1.414. If you have to use your calculator to get that, you can. So here would be over 1, and 1.4 is almost half. And then up or down -2, 1, 2. So here would be E. What about F? Well, pi 3.14, or just a little bit more than 3. So here's 3, just a little bit more than 3, and down 4. 1, 2, 3, 4. That would be point F. Point D, -3/4. Well, here's 1, and 3/4 is 3/4 of the way between it. So 3/4 and 0, so right there would be that point right there, which is what, D. So very simple to graph. we've got to move down a little bit. Let me erase this. This is all on a PDF, not a PowerPoint. Then we have some distance formula problems. I'm going to work one of these. I'll work this first one. Move it up just a little bit. Okay, I've got these 2 points. Tell me the distance between them. Okay, and it says round off if it doesn't come exact. So first I'll write the formula. D equals, I think that blue pen writes it a little bit better than this black one does. D equals 2 minus x1 plus squared plus y2 minus y1 squared and the square root of all of that. Okay. So putting in the values, if I call this 0.2 and I call this 0.1, then I first look at the x values here. Okay. -3 minus 3 squared. Now I'm going to look at the y values. -4 plus, minus 0 squared. Okay, so then I've got -3 minus 3 is -6 squared plus -4 squared, which is 36 plus 16, okay, which is 52. Square root of 52, which square root of 52 is square root of 4 times 13. Any of you ever heard of 52 card pickup? 4 kinds of cards, 13 of each. Okay, from the ace to the king. Well, we can extract this 4 and get a 2. So this is equal to 2 times square root of 13. And then I would have to look up on the calculator square root of 13 and multiply it by 2 and round it. Okay. As far as I'm concerned for this, that's good enough. You know, the only reason we would change this to a decimal is if we were doing graphing with it. Okay. Now, that being said, I'll leave this up here just a moment in case any of you need to copy it. Now, that being said, is in the next 4 days, we're going to go through this entire PDF. I need for you to be working ahead on this. So as I go over them, all you have to do is make corrections rather than make, writing every little step down by itself. If you can, try to keep your work inside the areas for each problem. If you can't, I suppose you could do it on scratch paper and attach it with just the answers here. Okay. All right. Well, that being said, we're going to stop today. Tomorrow, have this PDF printed off, and I realize it's lengthy. Okay. It's quite a number of pages. It's maybe as much as 21 pages. So at any rate, we'll see you tomorrow. Have a great evening, and that's where we're going to go. We're basically going to do a review. Now, I also sent you the chapter review that shows all of the skills as well, but you don't necessarily need to print that off unless you just want to. All right, unless any of you have a question, we're done.